Give me a few till I set up again. Hold on. Good. Now let's see. I don't know if anybody ever show up. Okay. Yes. So I need to be more, what's the word now? Aware. Need to be more aware. Yeah. Alright. Okay. Yeah. The simplest one of them all. Right? You know, say I hope. Wow, that's a little bit thin. That's thin. Alright, that look a little better. Alright, so if we're doing that, yeah, and then so I don't know what anybody else, but I do this. I color code my letter that I want. I color code it. So that way, the letter that I want stays on the left. Everything else goes on the right. Yeah. Alright, so when it's being multiplied, fine. Let me not even write it like that. If it is, oh, okay, that was good. If it is being multiplied, we divide. If we're dividing, we multiply. Yeah. They assume that we knew that. Alright, so then I remember the trick was them give it this rectangle and then tell you, like, let's say they say the area of it is, I'm trying to think of one, like 156 centimeters squared or something like that. And they tell you that the width of it is, I'm trying to come up with something that's not too, what's the word now? Let me see. 9. No, I'm not going to use 9. Whatever, fine. So let's say that the width is 12. Right? So the wicked people them know, because usually we are asked to find the area, right? And so if the length was 9 and the width was say 13, and you just multiply this by that. There you go, right? Then one day then flip it around. One day then flip it around. So another time then come to you and say, well, you have the length, you do not have the width, and they tell you that the area is 117 centimeters squared. And now, you have to figure that out now. You have to figure out, okay, how many I get W. And what they did not show you was this. They didn't show you that. At least they never show me. Right? So for me personally, the topic called transposing or changing the subject, as far as I'm concerned, it is the most important technique to master. Because without that, you can't do the triangle law of vectors when you need to do vectors, nor the parallelogram law. Parallelogram. I'm sorry for messing up the pronunciation, right? You can't do that either. So you have the laws of vectors, right? Without transposing, you can't even do regular measurement questions like things about area, things about volume, things about perimeter. You can't find the missing sides of anything without transposing. Even if you're doing sets, like intersecting sets, and like, so if you have something like, let me see if I have the space. So let's say you have something like this, and let's say X is in the middle, and then you have, let's say one over here is W, and then the other over here is S or whatever. Everything in here is 17, everything in here is 16. So therefore, W only is 17 minus X, and then this is only 16 minus X. Then, whatever they say the universal set is equal to adding 1, 2, 3 of these together. Yeah, you can't change the subject of the formula. You can't even do sets. Right? So changing the subject or transposing ties into everything. Ties into everything. Everything that you're going to do. Well, even if you, let me try to put it another way. Even if I tell you something like this. Okay. Hopefully all of that is actually in the board. Alright, good, yeah, it's there. Right. So yeah. Like how would you deal with this if you never know how to change the subject of the formula? So them have two terms. One of it is called an additive inverse, and the other one is a multiplicative inverse. And that's another thing. Vocabulary is important, but if you focus too much on vocabulary, you're never going to get around to actually doing anything. So, yeah, it's nice to know additive inverse. Inverse just means the opposite, right? Upside down, the other side. So the inverse of left is right, the inverse of right is left. Right? Inverse of east is west, and vice versa. So that's all inverse really is. Inverse, opposite. Argument done this one. So the same thing that we would do to solve something like this, we don't do the same thing. But with this is multiplication. With this is addition or subtraction. Right? So if you have a plus 17 and you want to get rid of 17, you have to use the same 17. But then what? You have to put a minus sign. Minus here and minus here. Yeah? So 17 minus 17, 0, 0 plus 9m is going to be 9m, right? So that is just 9m. And then now you will have 44 minus 17, right? So you can figure out what that is, right? So if you do 44 minus 17, well, if I take 14 from this and that, I would have 30 minus 3. So why not do that? I take my 14 from the two of them. So now I have 30 minus 3. Yeah, and then 7 plus 3, carry on 1, 3 minus 1, there you go. Alright, so 9m is equal to 27. Cool. Alright. Now, obviously I'm doing a little bit too much, right? We could literally skip what I just did if you understand what you want. No, this looks similar to this. The only difference between this and this is how it looks, right? The 9m is on the left here, but the 9w is on the right over here. So you can literally flip it around, and really the order don't matter. It doesn't matter, right? So when there's no space between the number and the letter, it means that it's being multiplied. Right, so 9 times m, yeah. Right, so we will have to divide both sides by this. We got rid of 17 before. Now we have to get rid of 9. So we have to get rid of 9 by using 9. Get rid of 9 over here by using the same 9. So we're minus 17 from the left and right. We divide both sides by 9 on the left and on the right. So now 9 divided by 9, that is 1 times m, that m, 27 over 9, that's 3, right? So ultimately, your answer would be m is equal to 3. Okay, good. I just want to be sure I can see that. Right. So, one of the things that I tend to go through a lot of the time is some of the things that I struggled with when I was going to school. I struggled with decimals, I struggled with fractions, I struggled with transposing. And then if you struggle with that in terms of just the basic geometry, the basic 2D shapes, it's going to affect you when you have to deal with polygons and what you call it now, the sum of all the exterior angles. Well, more like the interior, because the interior determines what sided polygon you're going to get. So if you have the sum of the interior being equal to 720, you need to figure out what side figure that is, right? And if your algebra don't go, trust me, right? So I don't know. I tried. Now here's another thing. So here's what I want to do. For me, I'm doing the fundamentals with City and Guilds, PEP, and CSEC mathematics, right? But I'm gonna write something. Hold on. Oh my God. I think something blowing on my face. I apologize for that. Yeah. What was I saying? This page I don't know if everybody can see that. Don't know. Go try to put some arrows to it so that we can focus on it a little bit. Yeah? So, that page, Instagram, TikTok, Facebook, YouTube, join anywhere you see it. We still learn, join that, because there's some things that I want to do with that. That's a lot more, it's a lot more expansive, right? More subjects from other teachers. Yeah, they probably delve into, yeah, a lot more. So English A, English B, you know, all the sciences, whatever it is that they're teaching. Yeah. Right? And then maybe what I can do is build up enough content over there with different teachers so that we can eventually start doing lives for this as well. So I want to actually work on that. But again, that's just little shameless advertising. Alright, but this is not about, right? This is me, but this is about everybody else. Alright? This is a little bit of selfishness, this is a little selflessness. Alright, so I'm just putting that out. Alright, putting that out. Alright. And now back to all of this. So yeah, so again, for me, when I was going to school, they played that little game with us, where they show you how to find the area, but not how to find the length or the width. And then it's even worse if you're doing the perimeter, because let's say they tell you, okay, let me do the maths on this. Let's say you have, alright, the perimeter of something could be, alright, give you an example. Give you an example. A quick one. Now, watch this, Joe. And this is why algebra is important, right? Watch this, Joe. Watch this, Joe. Imagine if you never know what the rectangle was, right? You never know. But they tell you that this is L and that is W. Alright, fine. Fair enough. That's L, that's W. But if this is L, this has to be L as well. But if this is W, this has to be W too. Now what you're going to do? You're going to add all four. So you have to add L plus W and L plus W. Right? Now, I don't know about anybody else, but I put a number 1 in front of them. So let me put 1 in front of this, 1 in front of that, 1 in front of this, 1 in front of that. Obviously, you're going to group like terms. 1L plus 1L is going to be 2L. And 1W plus 1W is 2W. So, in reality, this is how you end up with the formula for the perimeter of a rectangle. Right? That's how you end up with it. So therefore, even before you start doing any kind of calculation, so the first thing you're doing is, you're adding all the 4 terms. Then, you identify that L can be added to L, W can be added to W. Right? Now you have 2L plus 2W, that is how you get the formula for the perimeter. Right? I don't know if that was explained to me. I was told this, but I don't know if it was explained. And I think that's kind of what my goal is. To kind of go through things that I wish somebody told me when I was going to school. So for example, let me give you this. So Here's another thing. Right? Obviously we have opposite operations, right? For every plus there's a minus, for every minus a plus, for every multiply a divide and so on, right? Nobody did tell me this. Watch this. Suppose you have this. And you're multiplying it by, I don't know, maybe this. Yeah? Now I'm going to tell you a joke. Nobody told me that all you have to do is do this. Multiply it as normal and put back the decimal points. I learned that at a much later age in my life. I did not learn that in primary, did not learn that in high school. I don't even know if I learned that in college. I learned that when I started teaching mathematics. You can't make this up. You cannot make this up. Here's another thing you can do. Right? I don't know about anybody else, but I like making my own timetable of a particular number. So for example, you have this number up here, right? 256. What if I made a timetable of it? I only need 1, 2, and 3 because I have these digits here. I only need up to that. So I don't even need to make the entire timetable. I could, but I don't need to, right? So imagine I make 256, then 512, then what is supposed to know? 768. Remember, I have 1, here's my 1, 2, here's my 2, here's my 3. So I don't need nothing else. No, alright, let me put it somewhere else so that, you know. I want to put it somewhere so that it's still relevant, but I don't want it in the way, right? So we have this, and we have this, right? Hopefully we can still see all of that. Let me put a little, yeah. Alright? Okay. If I'm multiplying this by 2, well obviously 1, 2, so I'm going to use 512. Now, if you take 2 from 132, you're left with 130. Technically, you are now multiplying by 30 and not by 3. So how do you do that? You just add a 0 at the end of it, and then you just multiply by 3 as normal. Well, what is 3? 3 is this right here. 1, 2, 3. So you're going to have 768 in front of 0. Okay. Now here comes the easiest part. Obviously, when you multiply by 100, it's not 1 0 anymore, but 2. So you do that. But now it's just multiplied by 1, so you just put back the same number. Alright, so you have 256. Let me see if I can see all of that. Yeah, man. Yeah, we can see all of that. Alright, so now we're not going to use this again. We're done. Alright, we're done. Done. Done with all of that. Done with all of that. Done. Cool? So now it's time to do some little addition, yeah? Alright, so 2 plus the whole of the 0 there. Cool. 1 plus 8, alright. That is what? 12 plus 5, that's 17. Alright, this is one now. 13. Alright, good. Now, here's the fun part. Remember what I had before? Put back the decimal point then. And count the number of jumps you end up making. 1, 2, 3, 4. So now you jump back. 1, 2, 3, 4. Yeah? And I guarantee that if we put that in any calculator, we're supposed to see that. Right? We're supposed to see just that number there. So let me have a look. 2.56 multiplied by 1.32. I don't know. So little there we go. Now obviously I wanted the yeah, I don't know if you can say that. I don't know. Maybe. Yeah. Yeah. I wish I knew that. I think that's what this series should be about. I wish I knew this when I was going to school. Because there's so much I wish I knew, trust me. A whole lot that I wish that I knew. A whole lot. Right? Now, also, obviously, when you're young and you get this, you're just going to treat this like two separate entities. Right? Because obviously when you get more advanced, you realize you can factorize the two out of this. But again, you're not going to know that when you're in a primary school. You're not going to know that. But factorizing, you're not going to know about that. Factorizing is like that, you know, the CSEC kind of thing. I don't think anybody will start factorizing grade 1 to 6. I don't think so. Right? So, while you can factorize this, sometimes it's good to leave it like this, other times not so much. Right? So for example, let's put in some numbers and see what this would be. Let's say 30 plus, okay, let us say they said that the perimeter of this was 56 meters, centimeters, inches, whatever they give it. Right? So let's say they said that alright here, so they're saying the perimeter is 56 meters, whatever. Cool? They say that. Now, there's no way they can say that and not give you at least the length or the width. Right? Not unless they're trying to be CSEC, right? Yeah, you don't want that. So watch this now. So they give you, okay, let's say they say the width is, let's say they say the width is 13 meters, right? Yeah? So they say the width is 13. Now obviously you can put in 13 here and 13 there, indicating that when you multiply 13 by 2, you'll get what? You get 26. Alright, so let's put 26 right here. Let's put 26 right here. Now P is 56. So we'll put that right here. What are we going to do with all of this? What are we going to do with that? I'm hoping that. I don't know what I look for this thing. Oh wow, it looks a lot. It looks a little better than I thought it did. Alright, good. Yeah, alright, so yeah. What we're going to do? We're going to plus 26. What we're going to do with a plus 26? Or, here's my favorite thing to do. I don't know about nobody else. People will say that this is primary school. No, I don't know about nobody else. Let's say we have 2L. What if I replace the 2L with let's say I replace the 2L with this. With a box. That means that whatever in here, so 2L is equal to that. 2L is equal to whatever is in the box. So what number do I add to 26 that will give me the 56? I almost give you the answer. What do I have to add to 26 to get 56? Well, that number, obviously you subtract this from that. Or you can, if you want, you can count, right? So use yourself as 26, 27, 28, 29. Oh, wait. You know, I see my hand name. Sorry. Alright, so let's try again. So use yourself as 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. So far we have 20, right? 47, 48, 49, 50, 51, 52, 53, 54, 55, 56. Alright, so we have 30. Yeah. Anyway, that's if you want to be primary school about it, right? If you want to that. So now we have 30. That means if I write back this, I write back the 2L here, right? That means that the 2L has to be equal to 30. So if I write 2L equal to 30, I will divide both sides by 2. So if I divide this by 2, I get L. 30 divided by 2, 15. L is equal to 15. Right? So if I write it up here now and I say, well, here's 15 and here's 15. Now, this is how you prove that your answer makes sense. 15 plus 15 gives you 30. 13 plus 13, 26. This plus that gives you 56. Yeah? So even though we had just the 13, we use the 13 to find out what the L was. Right? Yeah. And people, these are the things that I feel this is the problem that I have. We're not saying that you shouldn't know these things, but they assume that you know them and they don't give you the foundation to take you to this point. Yeah, and that's one of the problems that I've had. Right? We always have a problem because when I was going to school, I couldn't understand why I couldn't multiply decimals without a calculator. Because nobody never showed me that. Why did I struggle with dealing with perimeter and area and when to do what? Because nobody taught me changing the subject of the formula. So the way I see it is, math needs to be taught differently, point blank. From grade 1 come right up, teach the maths different. And don't teach them just for pass exam neither. Right? We don't want to just teach you for pass exam. We want to teach you so that when you go to grade 7, you remember. When you go to grade 8, you still remember. Right? There's no point in you doing the exam. Then when you come out of exam, you don't remember. You know, we want to be a lifelong learner, if anything. Yeah? No, normally I do this at 8. I woke up late today, so, you know. Yeah. I'm hoping that in the future I can do this at 8 o'clock on most days when I decide to go live again. But yeah, today was one of those days. Today was one of those days. There is probably one more thing that I want to go through that I wish I knew when I was going to school. Right? I was having a little screenshot here. Right. So watch this. Something I learned when I just started teaching. Not something I knew before. When we start teaching, we learn this. As a matter of fact, no one will come up with this page. We still learn. That means that me still learn too. Alright? So yes. Join this on all platforms, right? TikTok, Facebook, Instagram, blah, 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 blah. Yeah. And that is for everything outside of mathematics, yeah? Now here's what I did not know. Let's say them tell you they want to turn this 7 divided by 16 into a decimal. So I would say, okay, so let's say you write this, which that's what it means. Alright. Now, just to avoid the confusion, this will go over here, this will go right here. So fine, the 16 go here, and the 7 will go here. Now back in the day, when I was taught this, let's stop right here, so. I can't go no further than this. At least, that's what I thought this was impossible. Nobody told me about this. You put a decimal point here, and you drop some zeros behind here. Okay. My favorite thing to do from this point is this. We have a 16. We're going to make a timetable of 16. Right? So 16 plus 16, 32. 48. 64. 80. 96. 112. 128. 144. And 160. Let's see if we can see all of that. Yeah. We can see all of that. Now, when I do this long division or short division technique that I show to the students, what I do is this. I underline the 7, and also we're going to pretend this decimal point doesn't exist. That way each time we're treating it like 70, then whatever number come after that. Right? So we have that. No. 7 is smaller than all of this. So if it's smaller than all of this, it means that if I go into the store with $7 and everything in there is $16 off, I cannot buy anything in the store. So if I can't buy nothing in the store, I will have to put what? A 0 up here. Then I move on to, even though it looks like 0.0, treat it like 70. 70 is bigger than what over here now. But it's not bigger than 80, so I could just stop right here. So it's bigger than 1, 2, 3, 4. So if it's bigger than 4 things, then you're going to put well, the number 4. Because you tick 4. 1, 2, 3, 4. So let's be literal. It's 4 things we tick. We're putting 4 up here. Now, for my comfort, what I do is I put a plus beside the 64 and ask what do I add to this to get the number 70. Well, I have to add 6 to that to get 0 carry 1. So 64 plus 6, that will do the trick, right? So 6 will go behind the 70, right? So we're done with 70 now, let's put the 6 behind that. Let me put that in blue so we're not confused. Alright. Now we're looking at the number 60. Alright, 60 bigger than what over here, so now? Well, it's bigger than 48, 32, and this, but smaller than 64 and the like. So this was 4, now it is what? 1, 2, 3. We're going to put what? That number up here. We take 3, so we'll put 3 up there. Alright. Same thing. What am I adding to 48 to get 60? You can even write it down here if you want. 48 plus what? Will that give you 60? Right? Do you know the timetable too? 12, 24, 36, 48, then 60. So that will be, well, you have to add 12 to this. 12 go after the 60, so let's put it after that, yeah? So we have 12 right here. Now, so we went from 70 to 60, now we're at 120. 120 is bigger than what over here. It looks like 112 going up. Smaller than all of them here. Right? You can take 3 from 10, that leaves you with 7. So therefore we're putting 1, 2, 3, 4, 5, 6, 7. 7 go up there. Alright. Now, watch this now. 112. What we add to 112 to get 120. We'll add 8 to the 2 to get that 10, so here we go, right? So now the 8 go behind that, the 8 is going to come here. Now we went from 70 to the 60 to the 120. Now we are at what? We are 80 now. So we went from this to this to this to that. Now we're at 80. But 80 is right here. Make a circle it for the full length. See there? And if I put so what? 1, 2, 3, 4, 5. Yeah? And just like that. Oh. Uniformity. Want it in red. So I'll put the number 5 up there. 80 plus what number will give you 80? That's going to be 0. Your remainder is in fact 0. Right? So wherever you want to put that. You want to put it right here, so you can do that. You can do that, right? Uh-oh. Run out of space. Run out of space. Alright. I can put it on here? Yeah, you can put it on so. There we go. Right. So I'm going to put the little, yeah, there we go. So the last thing that we have, the remainder is 0. So what is this? 7 divided by 16 as a fraction is really this number as a decimal. So it is 0.4375. Yeah. Funny story, if we were to try and bring this back to looking like this, yeah, there's a little method to the madness about that. So that I can actually show as well. You know. The beauty about that, hold on there. I'm trying to get this screenshot in. Alright, good. So let me see. So how could I go back from this to the 7/60? How could I do that? I think we had a good run of this. I think we had a good run of it. So let me see. I have enough space for the one more over here, so. Let's see. Let us see. focus is 7/16, right? Alright. Let me see what. Let me check and see. Okay, alright. No. So let's say you had this. And this is how maths usually work. So, if they give you this, then don't give you that. And if they give you that, then don't give you this. So it's not like anybody go tell you, say, okay, well, it's not like you want a clue. Right? So let me get rid of it. How would I go back to 7/16? How would I find that? How would I find that? Let me take the screenshot before. Yeah, I'll try to take the screenshot there so that just in case when I get rid of all of this madness now, you can just focus on the math that time. So okay, how do I get back to all of that? Now, every decimal is a fraction. Hold on. Let's see if we can move this. Alright, not terrible. Alright. Yeah. So every decimal is a fraction. So the joke is this. Now, without the zero and the decimal point, that number is 4,375. Put that up here, so. Argument done. We're not in a long talking, right? Yeah? So you put that up here. Now, how many times would we have to jump back to get to right here from here? We'd have to jump back 1, 2, 3, 4 times. So if it's 4 times, it means that we are dividing by a number that has what? 4 0. So you see all of this now? You have to put that under here. So that's your first step to turning it into a fraction, right? That's your first step. That's the simplest way you can do that, right? Okay, let me. Alright, good. Alright. So what do we do from here? Now, here's what I know. One of my favorite things to do is to use prime numbers to reduce a fraction. That's one of my personal favorite things to do. Also, once the number ends with 5, it's divisible by 5. The 5 time table is 5, 0, 5, 0, 5, 0, 5, 0, 5, 0, 5, 0, 5, 0. You're always going to get a combination of 5, 0, 5, 0, 5, 0. There's no part of the timetable of a 5 times table that ends with 4, 3, 2, 1. If it ends with 1, no. If it ends with 2, no. It has to end with 5 or 0. So this is clearly divisible by 5 and this too. So that is at least a step in the right direction, right? There's a trick that I love about powers of 10. One of my favorite tricks is this. You have 1 0, 2 0, 3 0, and 4 0. For every 0 that you have 2 times 5. So therefore, 1 0 means you have 1 2 and 1 5. But if you have 2 zeros, it means you have 2 2s and 2 5s. If you have, yes, I know that. We have 3 zeros, you have 3 2s and 3 5s. And naturally, if you have 4 zeros obviously I need to put the little multiplication signs to all of that. Now for the purpose of this part here, we're going to be using this. This we have to use. Right? So we're going to be replacing all of this with that. Hold on. Let's see if moving it up. Yeah. Alright, cool. Yeah. Alright. So again, I'm taking a screenshot just in case. Alright. Alright, good. Where am I now? So I know about that. And put down the 4 2s, 4 5s, right? 1, 2, 3, 4. 1, 2, 3, 4. Alright, so we have that. Now what about that up here? Alright, good. So, we have all that. Now, I am tempted to divide this number by 25. Because if you multiply 25 by 3, you get 75. So if you end with 75, must be divisible by 25. It might be divisible by 75 as well. We can test that theory too. So we have 75 for 375. Let's see if that works. Let's see. Let us see. 150, 225, 300, 375. What is now? 450 that. Make sure I say I eat that. Yeah, then 525. And we have 600. 675. Hold on. Oh, okay. You can still see, thank God. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 10. Cool. Yeah, hopefully we can still see all that. A little leanish. Really? There we go. Alright, so we have 75. 4 is smaller than all of that. So a 0 go up here. So 43 is still smaller than all of that. Right, so we're solving our problem very easily. Now we have 437. That is bigger than 1, 2, 3, 4, 5 on it. So we'll put 5 up here. Maybe I should have had these in blue. Maybe I should have done that. So we have the 0 here, 0 here, 5 there. Alright. What do I add to 375 to get 437? If I add 25 to this, I get 400. So let me add 25 to what? To 37. You can see that? Hope so. 5 plus 7, we have the 12, and then this is what? 5 plus 1, and this is 6, 2. Alright, so we'll take 6, 2. Really? Look at that. Look at that. A time waste, because it's divisible by 25 perfectly, but not the 75. Because if I put this in here now, there's no 625. See, that was just a test. That was a test. So, you see from it, divide it by 25. Right? That timetable is easier to come up with anyway. Right? Whole it easier. So get rid of that. I just do this real quick. Alright? So we have 25, 50, 75, 100, 125, 150, 175, 200, 225, 250. Alright, so let's do this real quick. Alright? Real quick. Start with the 4. Yeah, then go to the 3. 43 is bigger than this, so put on a 1. 25 plus 15 give 40, 15 plus 3, that is 18. So we'll put 18 in front of this. So we have 187. 187 is bigger than 1, 2, 3, 4, 5, 6, 7. So we have 7 of those. So we'll put 7 up here. Now what we add to 175 to get 187. 5 plus 175 is 185 plus 7, 12. So we'll put 12 right here. Yeah, 25 is the safe of it. So there we go. 125 is right here. So 1, 2, 3, 4, 5. Good. So at the very least we have 125 times, no, 175. Sorry. 175 multiplied by 25. Alright? But watch the joke. It's already in the timetable too. See 175 here? That means 175 is 1, 2, 3, 4, 5, 6, 7. This is 25 times 7. So that means, let us just change this to 25 times 25 times 7. Yeah? We can't do that. Alright. So one more before we get done with all of this. Alright. So now, what we know about 25? 25 is 5 times 5. So let's change the 25 into 5 times 5, and this into 5 times 5. Now, believe it or not, when we are reducing fractions, we're actually finding the HCF. This is really what you're doing. When you are reducing fractions, you are finding the HCF. Right? So, if we do this and say, well, we have 4 5s up here and 4 5s down there, that's what they have in common. So therefore, the HCF of this is 5, this is 25, 125, this is 625. So if you divide this and that by 625, you will end up with, if you cross out this, and you get back what we ended up with in the very first place. The numerator is what? Is 7. The denominator, 2 times 2, 4, 4 times 2, 8, 8 times 2. So we end up back with 7 over 16. Yeah? So, went a little bit over the time, so Right? Things I wish I knew when I was going to school. Things I wish I knew. So, I don't know. I'll try to go a little bit earlier in future, but I feel like for this week, I might be doing, 10, 10 a.m. every time I go live, it might be 10. So Wednesday, Thursday, Friday, I'm doing 10 for this week because chances are I'm going to be waking up late. Chances are. So, try and blow up this page, right? I'm not being too bad up here. This is alright. This one no. Yeah? Whether you're on Insta, YouTube, Facebook, TikTok, wherever you see that. As a matter of fact, the easiest thing to do is all of it is one word. Yeah. So we still learn on everything. Yeah? That's for outside of what I do here. Okay? So anyway, we're done.